What we're going to look at here is putting together everything we know about polynomial functions to do a graph by hand. So here we have our example. F of x equals x cubed minus 2x squared minus 6x plus 9. And we want to start by talking about end behavior. So remember that end behavior depends on the leading term. So it depends on the degree of the function, the degree of the polynomial, and the sign of the leading coefficient. So if you need to look those up to review them, go for it. Our function here has a degree that is odd and a leading coefficient that is positive. So for odd positive, that's going to be like y equals x cubed. So it's that kind of a graph. So we know that as x goes to negative infinity, f of x goes to negative infinity, and as x goes to positive infinity, f of x also goes to positive infinity. So usually when I have, once I know my end behavior, I just kind of sketch it like I have an arrow going up on the right hand end and an arrow going down on the left hand end. So that just will remind me as I'm drawing that my ends need to point up on the right and down on the left. Okay, the y-intercept. To find the y-intercept, we're going to substitute in 0 for x, and that's going to need to be in the form number 0, comma number. So if I put in 0 for x, 0 minus 0 minus 0 leaves me with 9. So my y-intercept will be 0, 9. So I'll go ahead and graph that right there, 0, 9. And then the roots and other points, that's where we do the list, test, rewrite. And the list, remember, comes from factors of the constant term over factors of the leading coefficient in our problem. Our constant term is 9 and our leading coefficient is 1. So our possible roots will be plus or minus 1, 3, and 9. And then test, we use synthetic division. If the remainder is 0, then we have a root. If the remainder is not 0, then we have another point on the graph. It's not necessarily a root, but it will be a point that we can use to graph our function. So let's test some values. How about, we'll start with 1. So I'll use my leading, or all the coefficients of my polynomial. Bring down the 1. 1 times 1 is 1. Add negative 1. Multiply again. Negative 1. Add negative 7. Multiply. Negative 7. Add 2. So x equals 1 is not a root, but we know the ordered pair 1, 2 is on our function. So 1, 2. Let's try negative 1. Negative 1, we go 1, negative 2, negative 6, 9. Bring down the 1. 1 times negative 1 is negative 1. Add negative 3, multiply positive 3, add negative 3, multiply positive 3, and that is 12. So negative 1, 12 is on the graph. Oh, that's kind of up in my writing here. Negative 1, 12. Let's try 3, 1, negative 2, negative 6, 9. So we bring down the 1, multiply 3, add 1, multiply 3, add negative 3, multiply negative 9, add 0. So 3, 0 is a root. Then we will rewrite. So f of x is going to be x minus 3 from this root times the row down here will be x squared plus x minus 3. And since this is now quadratic, we can use the quadratic formula. So x equals opposite of b plus or minus the square root of b squared minus 4 times a times c divided by 2a. So x equals negative 1 plus or minus the square root of, this makes addition, so 1 plus 12, so 13 all over 2. So this is actually two roots. X is going to equal negative 1 plus the square root of 13 all over 2, and x equals negative 1 minus the square root of 13 all over 2. And I would suggest that you use your graphing calculator to get decimal approximations so you can put them on your graph. Negative 1 plus the square root of 13 divided by 2 is 1.3 about, and negative 1 minus the square root of 13 divided by 2 is about negative 2.3. So we'll go 1.3, negative 2.3. And here's the point where we get to draw our graph. Actually, I want to talk about finding other points. You can use synthetic division or synthetic substitution to find other points. Let's say I wanted to know where the graph was when x equals 2. So I could put 2 in to my original row and figure out that, oops, that 1 has to just come straight down. And then 2 times 1 is 2, add 0, multiply 0, add negative 6, multiply negative 12, add negative 3. I could figure out that 2, negative 3 would be another point on my graph. So I could actually create more and more points in order to get a more accurate graph. So then I'm going to connect my points, knowing that I have to end up going straight up. So I come down through these points, and I can't cross through any points other than my x-intercepts that I put on there. Hit this point, I got to hit this point, I got to hit that point up there. I need to turn back around. I need to hit through this x-intercept and end up going down. Since the degree of my function was 3 and I found 3 roots, that is the end of my graph. Now, please notice that if I hadn't found this point 2, negative 3, my graph, I might have drawn it like this. And that would be okay because we're just estimating. But there is a way for your graphing calculator to help you locate those maxes and mins. What we would call this a minimum and this a maximum. And we'll show you how to do that on the other side of your page. So here we go with using a graphing calculator to find roots, maximums, and minimums. I will be working on a TI-83 Plus. They're so similar, the Texas Instruments, that you could probably use any calculator. We're going to start by typing the equation in y equals, and we'll use this one, which is different from the one we just worked on. But I'll type that in, negative 2 x to the third power plus 12x minus 6. So here we have, enter the equation you want in graph in y equals, and then we're going to press graph. Graph is right here. So I'll press graph. Now notice that my function is degree 3. I have 3 roots, and I can have 2 turns. So I know that if I follow my graph down, it has to turn around and come back up and go back down like that. So I need to adjust my window. So that says adjust your window accordingly. What I need to adjust is the y value that's down here at the bottom. So when I go to the window, I want to adjust y min, and I'll just pick a number. If that's not far enough, I'll pick a different number. But now that I can see that minimum, I know that I can find it with the calculator. Then we're going to be using the calculate feature to find what we're looking for, whether it's a 0, which is an x-intercept, or a minimum, or a maximum. And it's pretty much all the same kind of steps. I just want to sketch this on here because it's going to ask us to do things like left, right, and guess. And so I want to talk to you about what that means. So here's my function. Let's say I'm trying to find this root right here, this 0. Well, in order to be to the left of it, then my little cursor needs to be up above the axis. In order to be to the right, it would be down here. But if I was looking for this root to be on the left-hand side of it, I would need to be below, and the right-hand side I need to be above. On this one, I'll need to be up here for the left and down here for the right. For a maximum, you want to be over here for the left, over here for the right. For this minimum, this is left, this is right. So let's just go through the steps for finding these. Let's find this maximum first. So I'm going to go second calc, which is right here. That's the second feature for the trace button. And I want to find the maximum, so I arrow down and hit enter. And then it asks me left bound. So remember, left needs to be, the little cursor needs to be on the left side. And I hit enter. And then right, so I need to arrow my little cursor over to the right and hit enter. And then guess, I want to get close to it and hit enter a third time. That's going to give me an ordered pair. So my maximum is 1.41, 5.32. And I'm going to do that same procedure for the minimum. So I'll go second calc. This time I choose minimum. Left bound, I need to arrow my little cursor. See, here he goes down here to the left hand side. Hit enter. Arrow my little cursor to the right hand side of that point. Hit enter, and then get close to it and hit enter again. And that will be negative 1.41. Negative 17.31. And then for the roots, since there are 1, 2, 3 of them, I have to do that 3 times. So do second calculate. The calculator calls that a 0. Left bound, I'm going to work on this one right here. So my little cursor needs to be to the left of that point. Hit enter. And then right bound to the right of it. And then guess pretty close to it. So my roots are negative 2.67. Let's try this one right here. So second calculate the 0. I'm working on that one right here. So get to the left side of it, which I am now, enter. Get to the right side of it, enter, guess, enter. Now, sometimes your calculator will not give you 0 for your y value. Let's see if this third one will do that. So I'm working on this one. Go to the left of it. Go to the right of it. Enter. There we go. That one did it. So this is scientific notation. It means 1 times 10 to the negative 12. So that is a 1 with like 11 zeros in front of it. So that's pretty close to 0. So x equals 2.15 will be my third root. Sometimes your graph won't have any x-intercepts. Let's say I had x squared plus 3. If I look at that graph, it never crosses the x-axis, so it's